Good morning, everybody. You're on to MAMU with Jarvis. It's another time to learn mathematics. Our focus today will be on grade 10 mathematics. Our textbook of reference still remains our essential mathematics for SS1. Very good book. We'll focus on the aspect of maths today that pertains to algebra. Like I wrote geometry on the board, no, it ought to be algebra. Ought to be algebra, please. Sorry for that. Ought to be algebra, and we would be looking at practical solutions to problems today. Today we're going into solving problems in indices. Okay, now using this textbook, we're going to be working on exercise 4.2 that I've already forwarded to, for those of us having this live class, I've already forwarded this to your, okay, rather 4.3, I've already forwarded them to your WhatsApp. So I guess as I take the problems, you'll be able to see them and flow with me. Okay, and before I continue, I want a quick confirmation of whether you're hearing me very well. Send a chat, and if that's okay by you, I have started. Okay, so we start off with exercise 4.3, and then we start with question 1. It says, simplify the following, leave your answer in what? Index form. Simplify the following, leave your answer in what? Index form. So how do you handle this? Now look at question 1A. 1A says 3 raised to the power of 2 or raised to the power of 5. Now remember that we had applied a law that says when you have a to the power of x or to the power of y, it will mean, say, a raised to the power of x times y, which invariably becomes a raised to the power of xy. So when you have a setup of this nature, essentially what you're doing is that you are multiplying their indices, or the indices are being multiplied. So what you're going to have here will be equal to what? 3 raised to the power of 2 times 5. This will give me 3 raised to the power of what? 10. We go to question B, and in question B, we are told that x raised to the power of 6 all raised to the power of 2. Now, just to help our understanding a little, let me just go drop the standard a little for those who may be having an issue with coping with this. Now, this will be x raised to the power of 6 2 times, which will be like saying x raised to the power of what? 6 plus 6. What is 6 plus 6? 6 plus 6 also means 6 times what? 2. So this will be what? X raised to the power of 6 times 2. And that will be x raised to the power of what? 12. Now let's look at C. In question C, we have 10 raised to the power of 5, all raised to the power of 4. This will be 10 raised to the power of 5 times 4, and that will be 10 raised to the power of what? 20. Let's look at D. In question D, 1D, we have 5x times 4x all raised to the power of what? 2. Now, this is where the interesting work in indices begin. You know, I earlier said that the rules, it's not enough for you to just know the rules. The most important is for you to know when to apply them and how to apply them. If you watch this question now, there are 2 rules at play here. You need to start by trying to take care of this. Remember that, now take note of this, if I have a all raised to the power of 2, for instance, this will mean a to the power of 1, or maybe let's go back a little. If I write a, in my previous video I did that. If I write a, this is written as a to the power of 1, a once. I see that a what? 1. So a is a 1. So this one means what? 4 once, x once, all raised to the power of what? 2. So just doing this so that you can have an idea of what's actually happening. And this will be times 4 ones times 2, and this will be what? X ones times 2. So what does that give you? This will give me 5x times, sorry about that. That will give us 4x times what? 16 times x raised to the power of 2. All right, so with that, you're going to have 5 times 16. Now, take note of something. You're going to collect like terms here. So you have 5, or maybe we should spread them all out because we're just starting. 5 times x. 5x will mean 5 times x times 16 times x raised to the power of 2. And this will mean 5 times what? 16 times x raised to the power of what? 2. 5 times 16 will give me 60, 80 rather, and x, this will be applying your first rule now. You see what I was saying? You need to know what law you apply per time. This will be your first law. That will be x raised to the power of 1. Because I said here that when I write a x or a letter, it means to the power of what? 1. And that will give us what? Plus what? 2. When you multiply numbers, essentially you are adding their indices. So that will give you 80x raised to the power of what? 3, because 2 plus 1 is what? 3. So you've seen from this problem that it's not just enough to know the rules. You need to know how to use them. And that's where the math becomes very interesting. You need to know how these rules are being used. All right. So the next one, the E. In question E, we are told that 3x raised to the power x raised to the power of 0 or raised to the power of 3 times 5x. So this is now where it comes to how do you use the rule. Now remember, but x raised to the power of 0 is equal to 1. Remember from our knowledge of what? 0 index. So you see the use of the laws now, you need to remember them. Okay, what do I do at this time? So when you apply that here, it will now give you what? 3 times 1 or raised to the power of 3 times what? 5x. Are you seeing that? So you're applying the laws and you're taking them. Anything times 1 is that thing. So this will give you what? 3 raised to the power of 3 times what? 5x. Generally, we can multiply numbers, but I will advise you to simplify this. Now, please watch me carefully as I solve, because at some other point in time, I will not allow you expand out. Do you get it? So you must try to understand the reason behind. I think the key word here is decision making. You need to understand why at every point in time I think. All right, 27 times 5x. 27 times 5 will give me 135, and that will be 135 what? X. Now, when you multiply in algebra, when I teach children algebra, if I multiply a number times a number letter, the numbers will naturally multiply themselves. So 27 times 5x will give me 27 times 5 and then times x. So that's why we are getting 135x here. Okay, we'll give ourselves a little time to copy that and adjust. In question F, we have 4 raised to the power of 2, x raised to the power of 3, or raised to the power of 5. Now, take note of this. Maybe by this point, rather, let me do a little bit of observation here. If I have A to a certain power and I have B to a certain power, and all of them are to another power. The implication is that this power outside would affect this and will affect this. I come again. If I have this setup, please, I need you to be attentive to this now. If I have this setup where I have two terms multiplied all raised to a third power, this one will affect this and it will also affect this. So what you're going to have will be A, X, Z, B, Y, Z. Please take note of that because that's what you're going to be seeing play out now. Anytime you see brackets, you know, in bracket, we said in bracket, the bracket will multiply. I mean, the term outside will multiply everything in the bracket. In indices, the index term will do what? Multiply the respective indices in the bracket. So in solving, applying this knowledge here, what you're going to have will be 4 raised to the power of 2 times 5 and x raised to the power of 3 times what? 5. This 5 is affecting these individual indices. And this will now be 4 raised to the power of 10 and x raised to the power of 15. Now remember earlier I had said that when solving problems, you really need to be very careful. Not every to expand this one. The number you're going to get here will be 2. It is advisable to leave your. So please, let's watch and understand the decision-making process and the reason behind every of the decisions we are taking. All right. So that's for question F. Let's go to G. In G, we have x raised to the power of minus 8, negative 8, or raised to the power of what? 2. That will simply be x raised to the power of negative 8 times 2. This will multiply this. That's the implication. Twice of this. Twice of this one. So this will simply be what? X raised to the power of what? Negative 16. Here you are borrowing a knowledge from arithmetic. And I think I've done an extensive video on that. You may need to check up my page to find out more on this video. I've done an extensive video on that. Negative times positive or positive times negative will essentially give you what? Negative, right? So that's done. So let's go to H. In H, we have negative P squared Q all raised to the power of what? 5. Here we need to get a new law. There's a new law that will help us here. And I'm going to write that out very quickly. Now, watch this. If I have negative 1 all raised to the power of n, where n is an integer. N is what? An integer. What's an integer? I hope we know from my previous video that an integer is a whole number. An integer is a whole number that is positive or negative. That's it. It's a whole number. Please take note of that. So I've said that where n is what? An integer. This n is an integer. So what happens here? What will be the outcome here? So let's see what the outcome will be. Please pay attention to some of this understanding because these are some of the areas where it can get a little tricky sometimes. Now, if n is even, when we say n is even, it means n is an even number. If n is what? Okay, let's put it, write it out. If n is an even whole number, well, it doesn't really matter when we say even is even. What you have is that negative 1 all raised to the power of n will be equal to 1. Please take note of this because you're going to be seeing it in application soon. If n is an odd number, just keep it odd number, then -1 all raised to the power of n will be equal to -1. Let's take note of this. Very valuable principle I've just talked about, because this is what will help you handle a problem like this. So when you're given a problem like this now, so let's bring h back. When you're given a problem like this, how do you solve it? This is what you're going to do. This will mean negative. Watch what I'm going to do now. This is negative p squared q all raised to the power of 5. Now, what is this power? It's odd, is that not? Because it is odd, the answer will be negative. So this power here affects what this value will be. Come again, please watch carefully. This power here affects what this one will be. Because this is negative, because this is odd, this will be negative. See what I've said? -1 all square will give me that. Right? So this will now be negative p raised to the power of 2 times 5, applying the previous law you have learned now. So you see now that you're applying multiple principles. And then what? Q raised to the power of 1. Remember we said that if I just write Q, it is equal to Q raised to the power of 1. You see now, you see where you need to remember the principles. The order is not important. It's knowing the principles and knowing when to use them. And this gives me what? 1 times what? 5. So you see in this question, I have used close to 4 principles already. And this will give me negative p to the power of 10 and q to the power of what? 5. Okay, so we have done h. So let's go to j and I. Now in question I, you have x raised to the xy, y is raised to the power of 4, everything raised to the power of 7. Now, remember again, we said that if I write x, if I write a letter alone like this, it means this is to the power of 1. So maybe I should do this. So do that first. Oh, sorry, I've not forgotten. I wanted to use another method, but I think let me stick to one pattern. I've given a second thought. Let me stick to one pattern. Get used to that pattern, and then maybe when I introduce the other pattern, you will better appreciate what's happening. Right? So this will now be equal to what? X raised to the power of 1 times 7, y raised to the power of 4 times 7. And what does that give you? X to the power of 7 and y to the power of what? 28. You will see, discover here that the concept of, you're not to be taught multiplication here. Your multiplication needs to be very, very good. So if you discover you're a bit shaky in multiplication, you may want to go back and do some brush up. Right, then we'll go to J. For J, what you have is -7 x to the power of -3 y to the power of 2. Okay, y, everything raised to the power of what? 2. So how do you handle this? The first thing you will notice is that there's a negative here. What kind of index do you have here? It's even. So automatically, this term will be what? Positive. I seen that it will be what? Positive. So this one will automatically become this 7 to the power of 1, x to the power of -3, and y to the power of what? 1. I'm applying this principle, everything raised to the power of 2. Watch and notice what I have done first. What I'm taking care of this negative is the first thing you need to do. And generally in mathematics, the one sign you need to be very careful about when you're solving problems is negative. You need to be very careful how you handle negative in solving problems. Really must be very, very careful. Because more often than not, you can forget. And if you change a negative to become a positive, you have changed the problem. Right? So that's the first step we need to do, take care of that. But the next thing you want to do is to say 7 raised to the power of 1 times 2, x raised to the power of -3 times this 2. Remember we said that this will affect the content, and y raised to the power of 1 times 2. So what do you have? You're going to have 7 raised to the power of 2, x raised to the power of -6, and y raised to the power of what? 2. Please and please, indices is not testing your knowledge of how to find 7 squared equal to 49. That's what the topic is testing. And that's why when we start solving problems at some point in time, you discover that my take will be entirely different from what you are seeing in your textbooks. Because the objective of indices is to work and operate at the level of the index. That's why it's called indices. Mathematics at the realm of indices. Just like in the Marvel Cinematic Universe, you talk about something called the quantum city. So this is another quantum city mathematics. All right, so let's continue. I'll give us some time to take care of that. Okay, so we go to the next problem, and that will be question K. In question K, what do you have in question K? You have negative m squared v cubed, everything raised to the power of what? 4. So the first thing you need to deal with now is this negative. The power is even, so this becomes what? It will make this term to be what? Positive. So this will be m to the power of 1, because m on its own is m once. N squared b to the power of 3, everything raised to the power of what? 4. So at this point, you're going to have m to the power of 1 times 4, n to the power of 2 times 4, b to the power of 3 times 4. And that will be equal to what? M to the power of 4, n to the power of 8, and v to the power of what? 12. So that's what you're going to have. So it's discovered now that it's becoming more interesting. It's more repetitive in nature. So let's go to the next one. L. Negative 5 into 2 e to the power of what? 3, f to the power of 4, f all to the power of 4 rather. Now look at that. Notice that this one is what you is not affecting this, because this negative 5 is not in the bracket. So this will be equal to negative 5 times. And watch carefully. This will be 2 raised to the power of 1, e raised to the power of 3, f raised to the power of 1. Or let's put the bracket like that, all raised to the power of 4. Notice that I'm taking the problems step by step. I'm not in a hurry. One thing I notice sometimes when students solve problems, that sometimes you're in a hurry. You want to just know. Your brain needs time to see. The more you see the steps, the better you become at solving the problem. So from this, I'm going to have negative 5 times 2 raised to the power of 1 times 4, e raised to the power of 3 times 4, f raised to the power of 1 times 4. So what does that give you? This will give me negative 5 times 2 raised to the power of what? 4. E raised to the power of what? 12. F raised to the power of what? 4. What's the next thing? This will be negative 5 times, I can work with this. The answer here is quite small, so I can work with that. That will be 16. 2 raised to the power of 4 means multiply 2 4 times. 2 times 2, 4 times 2, 8 times 2, 16. All right. And that will be what? E raised to the power of 12, f raised to the power of 4. So what does that give you? That will give you negative 80, e raised to the power of 12, f raised to the power of what? 4. Are we seeing that? Okay, so that takes care of that. And that will be the answer to that question. All right, that's for L. So let's go to M. In M, we have 5 into a raised to the power of 4 or raised to the power of 3. In this same setup, watch, 5 is not in the bracket. I'm taking pains to emphasize this. I've seen this occur over time in problem solving. 5 is not in the bracket, so it's not affected by this. So this is invariably 5 times a raised to the power of 4 times what? 3. What does that give you? That will give you 5a to the power of what? 12. And what's the next one? The next one is n. And that is negative 4 into y raised to the power of 3 or raised to the power of 2. The same setup. This is not affecting this. So you're going to have negative 4 times y raised to the power of 3 times 2. And what does that give you? That will give you negative 4y to the power of what? 6. I seen that. So that's how it is being solved. All right. I thought I was going to be problem solving all the way because I really need you to understand this problem. And please understand something. My approach to teaching is quite different from what you would see. I try as much as possible to connect ideas. So you could hear me teach you this, and you may hear me talking about algebra. I mean, talk about arithmetic and things like that. The reason is this. I've often said is that my model of teaching resembles that of what the Marvel Cinematic Universe is doing. I bring the ideas. Sometimes I throw the ideas to you. Sometimes I take time to explain the ideas. Other times I take out time to collect the ideas together so that at the end of the day, you see that mathematics is what? Essentially connection between different areas of maths. So let's allow this to settle down and then we'll continue right after. All right, so we'll go to question O. 1O. And then it says negative 3p raised to the power of 5, raised to the power of 7, sorry about that, or raised to the power of 5. Now remember that this is odd, and because this is odd, this will be what? Negative. So this will be negative, bracket open, 3 raised to the power of 1, p raised to the power of 7, or raised to the power of 5. Now watch that. This one, I wanted to emphasize that this is there, and this will now be negative 3 raised to the power of 1 times 5, and p raised to the power of 7 times 5. What does that give you? That will give you negative 3 raised to the power of 5, and p raised to the power of what? 35. You don't need to bother to work yourself out here. This is what your answer would be. I've told us that indices essentially test maths at the level of the index. All right, so that's for O2. What will P be? For P, is going to be negative 8 into 2hk all raised to the power of 3. Take note of this. The negative, this power is not affecting this negative. This power affects the content of this bracket. So we're going to have something like this. Watch carefully now. Negative 8 times, or bracket open, 2 raised to the power of 1, h raised to the power of what? K, h raised to the power of what? 1, k raised to the power of what? 1, or raised to the power of what? 3. So this will be equal to negative 8. Please watch, 2 raised to the power of 1 times, or let's say times, 2 raised to the power of 1 times 3, h raised to the power of 1 times 3, k raised to the power of 1 times 3. This will give you negative 8 times 2 raised to the power of what? 3, h raised to the power of 3, and k raised to the power of what? 3. Now, some persons might say that is the answer, but that is where the new important idea in this topic comes to bear. Writers and instructors on this subject use different approach, but there is something you must take note of here. The concept of indices is best understood when you consider the base or the reference base as what? A prime number. So look at 8. What is 8? 8 essentially is 2 times 2 times 2. Is that not? So it means that 8 can also be what? 2 raised to the power of what? 3. So I can rewrite this to be 2 raised to the power of 3. Most students won't see that. And that will be negative 2 raised to the power of 3 times 2 raised to the power of 3, h raised to the power of 3, k raised to the power of 3. Now, look at this from your first law. If you multiply bases that are the same, what are you doing to their indices? You are adding them. So this will be what? Negative 2 raised to the power of 3 plus 3 h raised to the power of 3 k raised to the power of what? 3. And this invariably will give us negative 2 raised to the power of 6 k raised to the power of 3. I mean h rather, because we always write numbers in the order of the letters of the English alphabet, and k raised to the power of what? 3. So this is what your answer is going to be. It's quite different from the narratives we've been having, but this is the direction. I always tell us that I post the ideas gradually. This is the direction we're going to take. From this point, you're going to be seeing the concept of prime numbers. And by the time we hit on this so much, when you now face prime numbers in algebra, I mean in arithmetic, it becomes easy. You see that the topics and the aspects are connected. And that's what you must see first to become an outstanding mathematician. You need to see connections between the topics. All right, let's pause and have ourselves take care of that quickly. Now, what does Q tell us? Q says negative c raised to the power of 5 or raised to the power of 2 divided by negative c or raised to the power of 7. Right, so that's what the question wants us to take care of. Negative c or raised to the power of 2 divided by negative c or raised to the power of 7. Now, I always advise students for a question like this, there are two things you can do. Now, look at this. I hope you know that this is the same thing as saying negative c to the power of 5 or raised to the power of 2 divided by what? Negative c or raised to the power of 7, everything raised to the power of 1. I hope nobody is in doubt about that. There's no power here. Just as we would say that x is equal to x to the power of 1, that's the same application here for this bracket. Now, what number is it? This is odd. This is what? Even. So this will be what? C to the power of 5 or raised to the power of 2. This is odd. This is even. So this will become this. This is odd. So this will become what? Negative c to the power of what? 7. So invariably, positive divided by negative will give me negative. So that will be what? Negative what? C to the power of what? 10 over c to the power of 7. Now, watch something. Usually, we put the negative either on the numerator or on this. So I need students to be very careful. If I say negative a divided by b, I should have it like this or have it like this. If I say a over negative b, the answer will still be this or this. I see that it's important to take note of this. Very important to take note of this, because I sometimes will see students dropping the negative here. No, once you divide two numbers, the answer will be such that the negative, the denominator, the numerator carries the negative. So this will now give you what? This is this divided by this. So when you divide bases that are the same, essentially you are subtracting their indices. So this will be negative c to the power of 10 minus 7. That will give you negative c to the power of what? 3. You discover that I have really loaded you with stuff this morning. You've been loaded with lots of stuff this morning. So I want to beg, or rather appeal to you, go back and study these videos very, very, very well. Very well. Rewatch and rewatch. Just like watching some of these movies, the ideas that may, okay, this idea, I didn't get this thing very well. Rewatch and rewatch, and I assure you, once you do this, you'll begin to catch the concept very, very well. This is where MAMU with Jarvis for grade 10 class today will sign out. And I will trust you will go back and do your work. And in our next class, we'll be able to proceed even much more better. Remember, the two things that makes you an outstanding mathematician. 1, you must have the interest for maths. And 2, you have to practice. Thank you.